Look around you right now. The device you're watching this on, the room you're sitting in, the steady ticking of the clock, it all feels so solid, so continuous, and so absolute. But what if I told you the intuitive view of the universe you've held your entire life might be completely backward? Let's dive right into this explainer and explore the single most profound question in all of science. What is reality actually made of?
Think about it. What if space and time simply aren't real? Now, I want to be perfectly clear right out of the gate. This isn't some metaphysical thought experiment, and it has absolutely nothing to do with mysticism. This is hard science. Mathematics is currently pointing to a mind-bending conclusion. Space and time are not the fundamental bedrock of reality. They're emergent properties. Think of it like this. The concept of temperature doesn't exist for a single atom. It's an illusion created only when billions of atoms bounce against each other. Physics is suggesting that space and time work the exact same way. To see how scientists arrived at this staggering realization, we have to look at the greatest roadblock in modern physics.
Section 1. The ultimate physics problem.
For nearly a century, science has been completely split by two incredibly successful, yet deeply incompatible frameworks. On one side, we have Einstein's general relativity. It perfectly describes the massive cosmos, the smooth, curving fabric of space, the pull of gravity, the predictable orbits of planets. On the other side, we have quantum mechanics. This flawlessly describes the microscopic world, a chaotic, jittery realm of uncertainty, particles, and quantum entanglement. Both theories are proven to be astonishingly accurate. The massive catch? They fundamentally contradict each other. If you try to use the math of both theories at the exact same time, like when you're trying to understand the ultra-dense center of a black hole or the very instant of the Big Bang, the equations just crash. The math breaks down and gives you impossible, infinite answers. The leading candidate to bridge this gap and unite the physics of the large with the physics of the small is M-theory. Think of M-theory like trying to find the ultimate master blueprint of the universe. Proposed by physicist Edward Witten in 1995, M-theory is an 11-dimensional framework that unites several different string theories into one elegant overarching theory. In this framework, the universe isn't just made of one-dimensional strings, but also two-dimensional membranes and higher-dimensional objects called branes. But here's the massive practical problem. Testing an 11-dimensional theory to see if it actually works would require building a particle collider roughly the size of a galaxy.
Section 2. The Quantum Dot Experiment.
Obviously, we don't have a galaxy-sized collider lying around. So, how do we actually test this? In 1996, physicists designed a brilliant mathematical experiment known as the BFSS matrix model. They started with what are essentially 9 grids of raw data, mathematical matrices, living inside a zero-dimensional quantum dot. In this setup, there is no space, there is no time, there is just pure quantum information. But here is the mind-blowing part. When they scaled up this mathematical data to infinity, a process known as the large N limit, an entire 11-dimensional universe, complete with Einstein's gravity, dynamically generated itself out of the math. It's a lot like zooming into a seemingly flat, low-resolution digital image until suddenly a fully functioning 3D world spontaneously pops out. Gravity and geometry weren't programmed into the start of the experiment. They emerged entirely on their own.
What you're seeing here brilliantly illustrates the plane waves of scattering particles mathematically reacting inside that exact matrix model. It serves as actual mathematical proof that the physics of flat space, gravity, and colliding particles can be completely holographic. It proved that space isn't just an empty container or a box that things live inside. Space itself is manufactured by the quantum interactions happening in that completely spaceless, zero-dimensional dot.
Section 3. Wormholes and entanglement. If the matrix model hints that space emerges from pure data, another massive discovery tackles the physical structure of space directly. Back in 1935, Albert Einstein wrote 2 famous papers. One described ER bridges, what we now call physical wormholes, or shortcuts through the fabric of space. The other described EPR pairs, what we now call quantum entanglement, where 2 particles become mysteriously linked across vast distances, so acting on one instantly affects the other. For decades, scientists thought these were entirely different things. But in 2013, physicists Leonard Susskind and Juan Maldacena mathematically proved a mind-blowing conjecture known as ER equals EPR. They proved that wormholes and quantum entanglement are exactly the same thing.
To really put this into perspective, they mathematically demonstrated that if you take two black holes and quantumly entangle them, you are actually creating a physical wormhole bridging them together in the fabric of spacetime. Entanglement isn't just some spooky, invisible connection passing through empty space. Entanglement is the actual physical thread that weaves space together.
Section 4. The holographic universe.
This forces a total shift in our understanding of reality, leading us directly to what is called the holographic principle. Physicists studying black holes, like Jacob Bekenstein and Stephen Hawking, discovered that all the information, or entropy, falling into a black hole isn't measured by the 3D volume inside it, but entirely by the 2D surface area of its outer boundary. When applied to our entire universe, this means our 3D reality, including gravity, is completely equivalent to a 2D network of quantum entanglement. Just like a flat 2D credit card hologram contains all the necessary data to project a fully 3D image, we are literally living inside a projection broadcast from a lower dimensional surface.
Section 5. Beyond space and time. If space and time are just emergent byproducts of quantum data, we have to completely rewrite the story of the Big Bang itself. Enter the ekpredicate model. This model suggests that our universe might exist on a higher dimensional surface, or brane, that periodically collides with a parallel brane across an extra dimension. Imagine two giant hands clapping together in a higher dimension. Each collision causes a bounce, a fiery ekpredicate phase that fills the universe with matter and radiation, triggering expansion. It proposes a cyclic universe of endless deaths and rebirths, elegantly removing the need for time to have a singular rigid start date.
This paints an incredible picture of our exact origins. At the very birth of the cosmos, before space and time even existed as we know them, reality was just a chaotic, wildly entangled network of pure quantum information, a state known as a wormhole gas. It was only as the universe cooled below a critical temperature that this network went through a massive phase transition. Just like liquid water dropping in temperature and freezing into solid ice, raw quantum data literally froze into the smooth, continuous space and time we walk through today.
We've journeyed all the way from zero-dimensional quantum dots to colliding cosmic branes. The hard science is pointing to the staggering fact that space, time, and gravity are not the fundamental stage of the universe. They are the holographic illusion created by a vast web of quantum entanglement. So, I want to leave you with this final thought. If the very fabric of the universe is just a projection woven from quantum information, and you are a physical, biological part of that universe, what does that actually mean for human consciousness? If reality is fundamentally just data interacting with itself on a lower dimensional boundary, what are you actually made of?